All right, this is it, the finale of our Sentinel series. And we've saved the biggest idea for last. If there's one thing we've learned, it's that modern systems demand flexibility. The old rules don't apply. See, the Sentinel, it doesn't care about borders. In this new multi-cloud world, your data has to be just as portable as your code. So today we architect the Planetary mesh.
So, here's the plan. We're going to start by looking at the big problem, the cloud border problem. Then, we'll unveil the vision, what I'm calling the Planetary mesh. After that, we'll dive into the tools, looking at two heavy hitters, Spanner and AlloyDB. We'll architect our mesh, and then in the finale, we'll talk about why the ledger has to be global. Let's get into it.
All right, section 1, the cloud border problem, or as I like to call it, when your data is trapped in a confined kingdom. You know the drill, right? We build these amazing, powerful applications, but their most valuable asset, their actual data, ends up, well, trapped. It's confined to a single cloud provider's little kingdom. And this brings up a really critical question that every architect, every developer needs to ask themselves. Is your stateful application truly portable? I mean, really? Or is it locked into a single provider? Can you actually move it from one cloud to another without some massive, super expensive overhaul? Or are you kind of, building yourself into a cage, locked into one vendor's ecosystem? Because that really limits your options down the road.
And right there, that's the real challenge. Data is just so much less portable than code. Think about it. We've got containers, right? We can move our code around like it's nothing. But the application's state, its data, its memory, its entire source of truth, that's the heavy anchor holding the ship in place. It creates these high walls around your cloud environment, and that completely flies in the face of a modern, flexible, multi-cloud strategy. So, section 2, our vision for the Planetary mesh. This is where we create a unified data layer for a boundaryless world. To break free from that anchor we just talked about, you need more than a better rope, right? You need a whole new way of thinking. This isn't about small tweaks, it's a brand new architectural paradigm. So let's dive into this vision of the Planetary mesh. Okay, first things first. This whole vision starts by changing how we define our applications. We need to start thinking about them as stateful applications. What does that mean? It means the database isn't just some sidecar you attach. No, it is the heart of the application. It's the single, unified source of truth. And our number one job, our primary job, is protecting its integrity and making sure it's accessible no matter where the app services are actually running. On-prem, across multiple clouds, doesn't matter. And that brings us to the core idea itself, the Planetary mesh. I love this visual. Think of it like a global nervous system for all your data. It's this one unified data layer that connects everything. Your on-prem centers, your different cloud environments, and it makes those artificial borders between providers they just fade away. Your data can live anywhere. Okay, section 3, let's talk tools. To build something this ambitious, you need some serious firepower. And our first tool is all about global scale and managed dominance. Let's talk about Spanner. So, what's the big deal with Google Cloud Spanner? Well, its magic is really how it combines a few key things. It's not just some relational database. It's fully managed and, crucially, globally distributed. But here's the killer feature: synchronous replication. What that means in plain English is when you write data to Spanner, it makes absolutely sure that write is copied and confirmed across multiple regions before it gives you the thumbs up. This gives you something called external consistency, which is basically the strongest guarantee you can get. It means every single user, no matter where they are in the world, sees the exact same data at the exact same time. For mission-critical apps that need that kind of insane consistency, Spanner is the bedrock.
All right, on to our next tool, section 4, the portable tool, AlloyDB. This one gives us PostgreSQL power, but you can have it anywhere you need it. This is all about portability. And this is where AlloyDB enters the picture. Now, for any developer out there, the fact that it's fully PostgreSQL compatible, that's huge. You don't have to learn anything new. But its real superpower? Remember that heavy anchor we talked about earlier? AlloyDB Omni breaks it. It's totally platform independent. You can run this thing anywhere. Your own data center, GCP, AWS, Azure, you name it. This is how you literally tear down the walls of provider lock-in.
Okay, this table breaks it down perfectly. Let's just focus on that first row, portability. Spanner, it's managed by and lives inside Google Cloud. AlloyDB Omni, platform independent. It'll run pretty much anywhere. And that one difference really tells you everything you need to know. If you need insane, managed, synchronous consistency within the GCP world, you go with Spanner. But if what you need is freedom, the ability to have a powerful, consistent database across any cloud or even on-prem, that's the job for AlloyDB Omni. So you're choosing between depth in one ecosystem versus breadth across many. All right, section 5. We've got our vision, we've got our tools. Now it's time to architect the mesh. Let's look at the blueprints for things like portability, bursting, and disaster recovery. So, achieving true application portability, it doesn't just happen by accident. It's a very deliberate architectural choice. And you can think of it in 3 levels. The gold standard is what we call system-based portability. This is where you run the exact same database system, something like AlloyDB Omni, in every single place you might deploy. That gives you maximum consistency. A step down from that is API compatibility. Here, your app just speaks a common language, like a PostgreSQL client library. This gives you more flexibility, but you could run into some weird little incompatibilities. And the final level is functionality-based. This is where you limit yourself to only the most basic, standard SQL that works on any database. It's the most portable, for sure, but it's also by far the most restrictive. Let's look at a classic use case, cloud bursting. Imagine your normal day-to-day app is humming along in your primary location, let's say on-prem. Suddenly, you get a massive traffic spike. So you burst. You spin up a bunch of new application instances in a public cloud to handle the load. The whole point of the Planetary mesh is that those new instances can seamlessly and securely connect right back to your primary database, that single source of truth, without skipping a beat, no matter where it is.
Now, let's talk disaster recovery, because this is huge. You've got 2 main options, hot standby versus cold standby. A hot standby is exactly what it sounds like. It's like having a fully fueled identical twin of your database running 24/7, just waiting to take over instantly. Your recovery time, what we call RTO, is basically 0. On the other hand, a cold standby is more like having the blueprints and a pile of parts. If there's a disaster, you have to build the database from scratch and then restore it from a backup. Your recovery time is way, way higher. And this also hits your RPO, your recovery point objective, which is how much data you lose. With cold standby, you could lose every transaction since your last backup. The business impact of that choice, it's just massive.
And that brings us to the finale. Section 6, the ledger is global. You have the blueprints now. You know, our whole mission in this series has been about securing and ultimately liberating our most critical asset, our data. So when you put it all together, when you understand these patterns, and you deliberately choose the right tool for the right job, Spanner for that deep managed global scale, or AlloyDB Omni for that go-anywhere portability, you can finally build a data layer that's as dynamic and global as your business needs it to be. The bridge is built, the mesh is live. Your data is now free from those artificial borders. And really, everything we've talked about today boils down to this one single vital principle. Your goal as an architect is to build, maintain, and protect one unified source of truth. Make sure it's consistent, make sure it's accessible, everywhere, always. And that brings us to the end of the Sentinel series. Look, the ledger is global. The blueprints are now yours. So the only question left is, what will you build? Protect your truth and stay architected.